Hi and welcome to this Transition Year Higher Level Maths Algebra Revision Module video. This Algebra Revision module has been developed to help you to revise the Junior Cert Higher Level Algebra, which will assist you as you transition into the Leaving Cert Higher Level Maths course. So this video is going to focus on how we use the roots of the equation to create the equation itself. We're going to focus on using quadratic trinomials. However, I will talk through how some of these methods can be used and are extended onto polynomials of any degree. So this video is going to focus on three different methods. We're going to work backwards through factorization. We're going to use a shortcut that's specific for quadratic trinomials, and we're going to find the equation of a quadratic given its graph. So just to do a little bit of background about the roots, if you're asked to get the roots of an equation, it is the exact same question as asking you to solve the equation. When we're working in algebra, it's more likely that we see the question solve. When we're working in functions or with graphs, it's more likely that we'll see roots of the equation. From the picture here on our right, the roots are where the graph, in this case a positive quadratic, cross the x-axis. So we can see that there are 2 points where that happens, where x equals 3 and x equals -2. These could also be called the x-intercepts, or they may ask you specifically for the points where the graph cuts the x-axis. Do watch out for the difference in questions, because if they ask us for points, our answer should be in the form of points, which should be 3, 0 and -2, 0. So if we are using the roots of the equation to find the equation, we first must make sure we are 100% with how factorization works. So I'm going to work through the factorization method of solving a quadratic equation. So a quadratic equation here is given as 2x squared minus 9x minus 5 equals 0. From this we get a guide number of -10. We get that by multiplying the first coefficient 2 by the last constant, which is -5. That sign is really important. The negative means that whatever our factors are going to have different signs. So working that through, if I multiply 1 by 10 and they have different signs, I can work it through so I get my -9. So my +1 multiplied by -10 does give me -10, and +1 minus 10 equals -9. So our method here is we're trying to work out how can I split this -9x into two terms, which I will then which then means I can use grouping. So I'll have 4 terms, so I can use grouping. We've split that -9x into +1x minus 10x. Sometimes when you're doing factorization, you can get a little bit caught up, but I would definitely advise you to double check. Does +1x minus 10x give us -9x, and really focus in on those signs. In this case it does, so my next step is to factorize using grouping. So I group the first two terms and the second two terms, and then I get x times 2x plus 1 minus 5 times 2x plus 1 equals 0. At this point your check should be that both brackets are the same. If both brackets aren't the same, something has gone wrong. It could be as simple as you haven't taken out the highest common factor, you've just taken out a common factor, or it could be something got to do with how you factorize that guide number. Bringing these together, we get x minus 5 and 2x plus 1 equals 0. What's important to note here is this line here gives us factors. So these brackets, these are our factors. If the question was to simply factorize a quadratic trinomial, this is the point where we'd stop. But we're asking in this question to solve the quadratic equation, so we've one more step to go. So we take each of our factors, or each of our brackets, and we let each factor equal 0, and we solve for x. So we rearrange it to get x equals 5 and x equals 1/2. At this point, we have the roots. So that is our process. And what we're going to see now, as we work with the roots of any equation, but in particular quadratic, we're going to do this exact method, but work through it backwards. So, just an overview of what's happened. We start with the equation. We break it into smaller pieces that multiply together. They're our factors. And we let each factor equal 0 to then get our roots. So when we use the roots to build the equation, we're going to work backwards. So we start with the roots. We then get the roots into factors. We then get the factors into an equation. So if we let each factor equal 0, the opposite will be true. We're going to rearrange our roots so that it's something equals 0, which will create our factors. And if we were factorizing our equation to get factors, the opposite of factorization is multiplication. So let's see this example in action. Form the quadratic equation with the following roots, 4 and minus 2. So the first step in any question is to write the roots like we would see it at the end of a question asking us to solve. And that is x equals 4, x equals minus 2. Let's keep track of what we have. These are our roots. So remember, we're working backwards. So what we want is to get this equal to 0. So I'm going to subtract a 4 from both sides here. So I get x minus 4 equals 0. Here I get x plus 2 equals 0. So remember, we let each of those factors equal 0. So by that logic, we must have had a factor which was x minus 4. And we must have had a factor that was x plus 2. And they were both multiplying to give us 0. So at this line here, this is our factors. Now, if I want to multiply out that bracket, we split the first bracket, which is x times x plus 2 minus 4 times x plus 2. That equals 0. Multiplying that out, I get x squared plus 2x minus 4x minus 8 equals 0. And we get x squared minus 2x minus 8 equals 0. And we are back to our equation. So hopefully you can see at this point that it is the exact opposite to if we were using guide number to factorize and then solve.